Hello guys, welcome to Inside Electronics. So in today's episode, I'm going to show you how I bring back my dead lithium ion cells back to life. Now, here I'm talking about cells that are not completely dead. I mean cells that read 0 volts. I'm not talking about those cells. I'm talking about cells that are actually in the range of 1.5 to 3 volts. That is obvious because there is no point of charging any cells that is below 1.5 volts. That's the actual theory because normally lithium ion cells are designed in such a way that it stays at 3.7 volts at certain milliamp hour, and if it goes below certain threshold voltage like 3.2 volts for example, then it is not good for that cell. It can be discharged once, it doesn't matter, it may not matter, but long term degradation, like long time discharge of those cells continuously below those threshold value will certainly going to affect the capacity of the cell itself. In many cases, I'm actually an electronics person. I do salvage these kind of lithium cells from all available sources. So when I get lithium ion cells, like for example, I collect a lot of them from my friends and everyone and from electronic components. When I actually get it for the first time, they will all be having a lot of problems. Like you see here right now, this particular cell is now showing 3.43 volts. That is because this thing is just kicked back to life, and now I'm going to show you how I'm doing it. But when you actually get some of the cells, chances are some of them will be okay because some of them will be in the range of 3 to 3 point something volts and above. Those cells are perfectly fine and they can be bring back to life to its full capacity, no problem at all. Cells that are above 3 volts, those cells are really good. You will actually get 98% of the life back from it. And now the cells that are in the OK zone, the cells that are above 1.5 volt and below 3 volts, those are the kind of OK cells that hopefully will bring back, they can be brought back to life, but hopefully will give you uh, almost 95% at the best of full capacity. Normally anything above 75% up to 95 up to 90% can be expected from the cells that are 1.5 to 3 volts. Anything below 1.5 volts, you don't want them to be charged at all because it's not worthy enough. Even though you charge it, trust me, I do have a lot of 18650 cells and I have charged and discharged them a lot. And trust me, cells that are below 1.5 volts, for example, those sometimes they are 1 volt and 0.6 0.5 volt, they will take a charge but only like a couple of 100 milliamps. That is not even worth the amount and the time that is spent onto it. So ignore anything that is below 1.4 volts, like 1.4 1.5 volts. Okay, so now let's do what I want to show you guys. Oops. Unexpected thing caught on camera. I actually shorted the battery and it gave out flames. The wire, as you can see here, the wire is melted. Wow, that's really unexpected. You can see the wire is actually sticky right now. I don't think, did I caught that on camera? I don't know, but anyways, I'm just going to proceed there. See, this is why I'm telling these kind of things are dangerous. You really have to be prepared for anything. I was about to burn my, oh my god, I almost brought my workbench on fire. So I just used a couple of magnets right here, and what happened is that the other end got disconnected from here and it got short circuited. So that is an obvious danger. If you are trying to recreate what I'm doing here, do it at your own risk. You just seen it in action. Do it at your own risk, okay? So you have so the voltage of this thing is now, oops, there goes the camera. This episode is full of bloody Murphy. This thing is now 3.7 3 volts, it dropped because of the short circuit. But anyways, now this thing is ready for charging in this one. I will show you that later, but now I'm going to connect a bad cell to here. So I took another cell. Let's measure it beforehand, and as you can see, it is 1.47. It's 1.5 volts, no problem. So the first thing I'm going to do is fix my camera. Okay, I hope that's fine. Yeah, okay. So I'm going to attach it, the negative to the negative, making sure that I don't want my table to be on fire. And I'm going to attach this magnet over here for added pressure, and the positive to here. And by the way, if you have noticed, that negative terminal has already came out of the magnet. Anyways, it's horrible. I'm just going to attach it like that. I'm going to keep it here. There's another magnet on top of it, negative going into there like that. Okay, now that is connected. Let me show you the voltage once again before starting this thing. It's 1.47 volts. Now the power supply that I'm going to use is the important thing. I'm using a 5 volt 150 milliamp hour linear power supply. This is not an SMPS, this is a transformer based power supply, and that is important because I will explain what happens if you are not using it in the end of the video. I will be telling you about the do's and don'ts after it. So I'm going to plug this right now. No bang, that's good. So now I'm going to show you the voltage. As you can see, it instantly is rising. Let me make the polarity correct here. The negative is now attached to the negative, and I'm just going to keep the positive this side here itself, touching it, and nothing is showing. Yeah, there it is. As you can see, the voltage is gradually climbing to 3 volts. Now that is a good thing because we want this thing to be charged to 3.3 volts. That's the maximum that I will charge this thing from by using this 5 volt power supply, because it will actually, the power supply is still capable of giving out 5 volts. Even though the output current is low, it will still raise the voltage of this cell to 5 volts if left unattended for a long period of time, which is really dangerous. You don't want the voltage across any lithium ion cell, you don't want the voltage across it to be raised above 4.2 volt. That's the maximum. But here we are actually trying to boost it, we're trying to bring it back to life. So we do want to get this raised to 3.3 volts limit. Now there are a few points to be noted at this time. If the cell voltage is not rising, as you've seen here, the voltage started to rise instantly. It only took a few seconds to reach 3.1 volts right now. So if your cell is not doing it, if your cell is not charging, if not the voltage is not raising to 3 point something volts, even after say a couple of minutes, say 5 minutes, if it's staying at 1.5 volts itself, or if it's not growing fast enough, then it clearly indicates the cell is bad, the internal resistance, or something is really bad about it. You do not want that cell to be charged at all. Just ignore that cell. That cell is not good. But instead, on the other hand, if the cell voltage is rising just as we see here, in a few seconds, if the voltage is up to 3.3 volt, that clearly indicates the cell can be brought back to life by using one of the regular 18650 chargers. Now, what do you want to note? I mean, what you want to note is that once the cell is up to 3.3 volt, you have to unplug it from the wall socket. From the 5 volt power supply has to be disconnected, and you want to keep these two wires has to be disconnected also, and you want to left the cell for a few hours in that voltage. you want to check whether the voltage stays at 3.4 volts itself. If you notice the voltage is falling down below 3.4 volts, if it's going down, if it's gradually discharging on its own, that indicates the cell is a bad cell. You do not want to charge that cell again. If a cell stays for 3.4 volts or 3.3, a slight drop is okay, but not a huge drop is not okay. A huge drop is not okay. If the cell stays at 3.4 volts, then it's fine. You can then transfer it to an 18650 charger, or in my case I'm using a power bank over here to charge it. Now once it's 3.3 volt, I will transfer it to here. As you can see here, I have already placed one over here. Now when I plug this power bank on, it will charge this cell to the maximum voltage that it can handle. Now you do not want to stop at that point. Once it is fully charged, you want to discharge the cell completely, and you don't want to stop at that point either. You do want to repeat that step a couple of times. Only after that you have to use a power meter like this one over here if you like, because this will give you a good indication of how much power has been transferred, how much your battery capacity is if you use one of these. Now I have a full review of this on my channel. Click the I button up here, it will take you to that video if you haven't watched that before. So once you fully discharge and charge this thing a couple of times, make a full charge and discharge via this thing. That will help you identify the capacity of your cell. So right now, as you can see, in the meantime it is reaching around 3.2 to 3.3 volts. I'm going to turn off the power supply. I'm going to leave this thing unattended for a few hours, and after that, if the voltage is still at 3.4 volt, I will be transferring it to here, and I will charge it. I will discharge it a couple of times. I will measure it, and that's it. So the things that you do not want to do is, first thing is, this method is not the recommended method at all. This is the way I do it. Even though it works for me, it may not work for you, but it works for me anyways. But that's what matters for my kind of works. And do note that this is really a powerful device. As you've seen in this video itself, if you short across this, it has a great potential for destroying things. The most important thing that I want to mention is that you do not want, I've seen a lot of people trying to charge 18650 batteries by connecting them in parallel like that. A good cell in parallel with a bad cell. You do not want that to happen, because if a good cell is connected in parallel with a bad cell, what happens is that a huge amount of current is going to flow from one to the other. It's going to heat up the cells very fast, and because you don't know how bad the other cell is, it can create a short circuit, which is literally, which acts like a short circuit itself. You are actually shorting the good cell on its own. You don't want that to happen, so do not try to do that. And the last thing is that do not use an SMPS based power supply like the phone charger that you get. Now these SMPS power supply will actually keep the voltage at 5 volt itself, no matter how much current you draw from it. That is actually bad for what we are doing here. You need a soft and gentle amount of current to be flowing across it, because you are trying to wake it up. You are not trying to fully charge it from a long years of a sleep. You want to be gentle on it at first, so you need a low current to be flown across this thing at the beginning. Once the cell has got its capacity back, you can then use a regular charger, and a high current charger, no matter that. So at the beginning, you really need a current limited power supply. If you don't have a current limited power supply, you can use a low voltage power supply, low voltage low current power supply like the one that I used to do the job for you. But anyways, avoid using an SMPS based power supply for the initial kickback. Now once the cell is brought back to 3.3 volt, you are good to go. Your cell is now alive. You can transfer it to here to check for the capacity and make sure if it's worthy enough to hold on to. So guys, one important thing that I forgot to mention is that you do not want to charge your dead battery using the regular chargers like the power bank. The reason why is two things can happen. If the cell is damaged internally, it will act as a short circuit, shorting out the terminals completely, and it can damage the charger. Or the second, the most likely thing that can happen is the cell won't take a charge at all. The reason why is because these chargers are equipped with a low voltage protection, so it won't initiate a charge until it has detected certain amount of voltage on the cells its own. So because of that, the protection circuit may kick in, and when you plug it in, nothing will happen. That is the most likely thing that can happen. So unless your charger specifies that it can wake up dead cells, there are special chargers available for that. Unless your charger states that clearly, you do not want to try to wake up a dead cell using your regular charger. It can ruin your charger itself. And the second thing is, do not use a high voltage low current power supply. Like I'm here using a 5 volt. You can use a 9 volt and 12 volt battery chargers, but that will actually bring the voltage quickly to 3 volts, but that is not recommended. You want a slow rise, you don't want a sudden rise of voltage. So do not use higher voltage chargers. And also, if you want to be on safe side, you can use a diode in series with the 5 volt output, so that the voltage will fall to 4.3 volts. It is in the safe zone anyways. So that's it. Thanks for watching, and see you in another video.